Hello guys, in this video we are going to solve computer exercise number 4 in the chapter number 2 of Introductory Econometrics by Wooldridge, 6th edition. So we are going to solve this question. So you have to download the data set given on the companion website for the textbook. Download those data sets. You can download there are multiple number of options, that is you have R files, eViews files, Excel files. I have downloaded the Excel files. So this is the data set that we have. In total we have 935 observations, and these are the variables for which the data has been collected. So you have wage earned by an individual, weekly hours worked, IQ score, education, experience, and so on and so forth. So I've also put the question here so that we need not go back again and again to refer to the question. So let us, start solving the questions. First question is fairly easy. It just talks about find the average salary and average IQ in the sample. What is the sample standard deviation of IQ? And it is also given that IQ scores are standardized random variables with a average value of 100 and standard deviation of 15. So I have solved this answer. So average salary is nothing but you apply the average function and input the number of observations given under the wage. Similarly, you go apply average function on the observations given under IQ score. And finally, we are talking about sample standard deviation of IQ score. So you must understand that IQ scores or IQ score is a standard random variable with mean of 100 and standard deviation of 15. So standard deviation of this entire sample must also be around 15. So you can see sample standard deviation of IQ score is 15.05, which is fairly very close to value 15. Okay. All right. Now, second question talks about estimate a simple regression model where a 1 point increase in IQ changes wage by a constant dollar amount. So again, guys, this is a simple regression model. So the equation will be, wage will be a dependent variable. There will be a constant term, that is the intercept term. So wage is a function of beta naught. Beta naught here I have got through the regression. I'll tell you in just few seconds how I have got this. Beta naught plus beta 1 times IQ. Beta 1 is nothing but your slope estimator. So, to solve this question, I have, used data analysis given in the Excel. So you go to data analysis, you click on regression. When you click OK, you'll be asked to give the input Y range. So in the first model, since I have to obtain a regression of Y value on IQ score, so I take input as so for this input I'll have to go to this page, and this is the last file that I've done, that is for answer 3. So you have to select this as your Y range, and X range, that is your dependent variable, that will be your IQ score. So you have to select this, and then you set your confidence level to 95%. I'm not selecting constant is 0 because I am assuming that a constant term is present in my regression model. So when you go to answer 2 page, this is the regression summary that I have got. So if you see here, this is coefficients, standard error, t statistic of the coefficients, p value of this t statistic, and these are the lower and upper confidence intervals. So you see the value of constant term is coming out to be 116.99. So I have written here as 116.99. And value of x variable, and here x variable is nothing but IQ score. So IQ score value is 8.30. So our regression equation becomes, and mind you, this is the estimated regression equation. That's why I've not written any residual term over here. So my regression equation becomes wage is equal to 116.99 plus 8.30 IQ. Okay, all right. So question asks me use this model to find the predicted increase in wage for an increase in IQ of 15 points. Does IQ explain most of the variation in wage? So to answer the first part of the question, change in wage, that is del W due to change in IQ score by 15, will be nothing but the slope estimator times the change in X value. So slope estimator is 8.3 multiplied by 15, that is IQ score has increased by 15. So if there is an increase in IQ score by 15, my wage or wage earned by an individual on an average will change by 125. I think the unit is dollars, so we'll say dollars. So if IQ increases by 15 points, the average wage earned by an individual will go up by $125. So this is how you should be interpreting the question. So second part of the question asks me, does IQ explain most of the variation in wage? So in turn, it asks me whether the model that we fit is a good fit to the data or not. And this can be looked at from the value of R squared and adjusted R squared that we've got. And R squared value is pretty low, that is almost less than 10%. So this model only explains 10% of variation in wages. That is, IQ score only explains variation in wages to the extent of 10%. This is how you should be interpreting. Okay, all right. So the third part of the question, now estimate a model where each 1 point increase in IQ has the same percentage effect on wage. So now it asks me that your IQ score remains, in the same unit, but now you have to talk about percentage effect on wage. So now my dependent variable will no longer be wage in raw, values, but it will now become log of wage. So my regression equation in this case becomes a semi-log model where I have dependent variable in log and independent variable in IQ score. So I'll follow the same steps. I'll go to the data analysis tab. I click on the data analysis tab. I go under regression, click OK, select my Y variable, select my X range, and the regression results are summarized here. So you can see the value of intercept in this case comes out as 5.886994, which I have rounded off to two digits, and I've written it as 5.89. And the value of coefficients I get as 0.0088. So this is my estimated regression equation. So log wage is equal to 5.89 plus 0.0088 times IQ. Now the question asks me, if IQ increases by 15 points, so again same increase in IQ score, what is the approximate percentage increase in predicted wage? So again I have to find del W, that is del Y. So change in wage, you must understand, will be equal to 0.0088, that is slope estimator, times change in the IQ score, that is 15. So this is 0.13. But mind you that in this case my dependent variable is expressed in log terms. So here what is happening is a change in unit value of X explains a change in log value of Y. So this is my proportionate rate of change of wage with respect to a unit increase or a given increase in IQ score. So in order to talk about percentage change, I multiply this proportionate change by 100. So almost 13.2% increase is given by this regression model. So how do we interpret this? If IQ score increases by 15 points, on an average, wage will increase by 13.2%. So this is the solution to this question. I have also, solved this question on R. So let me just take you there. So on R, first I have set my working directory because the file that the Excel file is saved on my desktop. So I set my working directory. So set wt, and this is my working directory. Then I give a name to my CSV file. So wage2 I have given it as a name. So wage2 is read.csv, and this is the file that I have saved on my desktop. This is head gives you initial six number of rows and columns of your entire data. So this gives me initial six observations on all the variables. Now I have fitted a regression for the first question, that is question number 2, that is estimate a simple regression model where a 1 point increase in IQ changes. So in this case, I have to estimate a regression model. So I have written wage model. LM stands for regression on in R. So wage, that is raw values of wage, is regressed on IQ score, and the data is wage 2. So summary of wage model will give you the results of the regression. You can cross check it. The value of coefficient turns out to be 116, as we had got in the Excel calculation as well, and IQ score comes out to be 8.30. We are not talking about t value and probability of this t statistic. We talk about this when we talk about hypothesis testing in regression, in the context of regression. There we talk about how do we interpret all these significance significance given in the summary. So in order to answer the third part of the question, I'll regress not wage, but I'll regress log of wage now on IQ score. So this is the summary of third regression. So estimate value comes out as 5.8869. So rounded off to two digits as 5.2 decimal digits as 5.89, and the value of IQ score, coefficient of IQ score, comes out as 0.088. These are the same results that we had obtained here as well. So you can solve this question in any of these softwares. I've used Excel and R, and it depends on your convenience which software you want to solve this question.